questions that you want to ask orally, please use the raise hand feature, and I'll take them up after the questions in the chat box are covered. Okay, so just give me a moment. Okay, so I'll also request the speakers, Vikrant, Vibhu, Atri, Dipti, and Arpit to keep your mics on, and if you can put your videos also on. Okay, so let's start with the first question. So I think, yeah, maybe you'll have to switch off your audio for a while because it's feeding back. Yeah. So the first question is from Sridhar for Vikrant and Vibhu. Wondering if you have specifically looked at deep learning frameworks such as TensorFlow, PyTorch, and others on impact of energy consumption?
Yeah, so actually that's a good question. That is one of the experiments that we are also doing. And we have some early results in that where we actually saw that PyTorch is actually not as good as the others, but yeah, that is one of the areas of experimentation that we are doing.
Okay, we'll move on to the next from Raghu again for Vikrant and Vibhu. So Raghu says it's a philosophical question. Should we now stop calling systems as AI systems and call them as AI aware systems, both from a sustenance perspective and from ethical perspective?
Yeah, so surprisingly, the answer which I wrote on the chat was deleted, but I will try and be, I don't know who did that, but I'll try to be as close as possible to what I wrote there. Okay. In a way, this has been a problem that we have seen even in the company and generally in the field, where there is a artificial demarcation or a separation of what is meant by software and what is meant by AI. And what that leads to is a separation of concerns when it comes to building software that has any AI techniques integral to it, right? Towards that, I think what Raghu mentioned is correct. We probably have to now start calling them AI-aware systems or intelligent systems, as some people call it, where the traditional software considerations when we design, develop, test, maintain these systems, along with the newer considerations that AI may bring into those newer systems, can be looked at in a holistic manner, right? And I think that has an impact both on the intrinsic sustainability or sustenance of that system, as well as from an ethics perspective. I think having that unified look at what is the role of software, quote unquote, and then what is the role of the AI that is part of that software. That again, from an ethical perspective, I think we would have a more richer discussion if there was no artificial barrier between the two. I mean, that's what I understood from Raghu's question, but happy to discuss that now or later.
Yeah, probably. I think we'll take it back. I see Raghu raising his hand, but we'll take it up after all the other questions are addressed. Nitin has again a question for you too, Vikrant and Vibhu. An additional setting may be to try early stopping in DL models, in deep learning models, which stops the epochs if validation accuracy goes down, indicating overfitting. I mean, it's really more a comment, I believe.
Yeah.
It's
So that is a valid point, I think. So that is not a specific stopping point that we've taken in the energy experiments. It can be used, but in some experiments, what we saw was that there is an intermittent phase where the accuracy does not increase for quite some time and sort of hovers around. So maybe it is sort of learning a few features, and then after some time, it again starts to increase. So I think some of those heuristics, if we use them, have to sort of take into account the width of that period. But really, the perspective that we had was that suppose you reach that point, and then the energy that is needed in some is sometimes 4 times more energy to maybe even increase just 1% of the accuracy when you're already at say 90+%. So does that justify or not? So the idea is more to bring out some of those insights and the importance of bringing out those insights so that somebody can take an informed decision.
Okay. Again, a question from Sridhar for you too. Should we essentially focus on consumption of energy on data and its usage, as that consumes more energy? How about he says instead of trying all ML models for a problem, I mean, yeah, all different types of ML models, I think that's what he means. And can we develop a tool that can give prioritized models in a particular given context?
So you want to take that, Vibhu? I can add to that later.
So yeah, I mean, that is interesting. The perspective that we have here is obviously that we are presented here is around the training time energy usage, and it will be important obviously, for example, if we start to look at the production or deployment time energy usage, and those are some of the directions that we are taking. But yeah, Vikrant can add to that.
No, the see, one of the things which I figured from Sridhar's question was was that related to the prediction time energy consumption of the models? And if yes, then that is a piece of work that is important to consider, because the scale of the consumption during prediction time, or the production time rather, is going to be very large. So each action taken by the model might not lead to a very large consumption, but then cumulatively, given the scale of these model usage, that would lead to a higher energy consumption. So I think selecting the model that also behaves well during production is important.
Yeah, that's true. We will take up the next question. This is, I think, for Arpit from Rahul. How often do you need to retrain your model to ensure that its performance does not degrade with time?
Hey, Ravindra. So actually, this question is for me, Atri, I think.
Wrongly written.
Yeah, I had.
Okay, sorry.
Yeah.
Yeah, so actually, I'm really sorry. I think the video is not working for me due to some technical issues. I hope that's fine. Hope I'm audible, I mean, clearly.
Yes, you are audible.
Yeah, you're audible.
Okay, so let me take that question. So basically, one of the main things that we did. So I'll answer this question in two parts basically. So the first and the most important thing that we did for retraining is that we made our system immune to immediate disruption. So I mean, sometimes because of business related issues and things like that, there will be immediate disruptions in the data, like some resolver groups get merged, sudden renaming of groups and teams, problem shifting from one group to the other, and stuff like that. So in order to handle these immediate disruptions, we use the rule engine. I mean, we know that even if we train the model, every hour, we will not be able to catch up with these changes in time. And I mean, we will keep misclassifying. So ML will take its own time to catch up or train, because with 20 tickets or 30 tickets, you will not be able to train. And anyways, you have trained on maybe 100,000 tickets, so it's biased on that. So that is one thing. So that's why we don't really need to retrain very frequently. However, to get the to catch the concept drifts and the long-term changes, you definitely need to retrain. And I would say that we should keep that configurable. We have kept the configuration value of 1 week for most of our accounts, and that works pretty well. But I mean, if we think that the volume of the data is huge, I mean, maybe 100,000 tickets a day or something like that, then even 1 day should be good enough, because you will have enough tickets to train on even on a day. So it depends on the data set, obviously, but I mean, two parts. Like one is to have the immediate disruptions handled by business specific rules, and as we did, like we augmented the rule engine with the machine learning so as to remove the disambiguity in the first place. And the second part is to have a decent enough data set before we do the retraining. So the periodicity has to be like that.
Okay, thanks, Atri.
Yeah. So Atri, just a related question I had in this space. So you mentioned about this rule engine, and a rule engine is a fallback option for the poor or bad classification. So how do you decide that your classification is really poor or bad? What is the mode or the criteria for you to switch over to the rule engine?
Yeah, correct. So now the thing is, I mean, the way we design the pipeline, we don't actually switch over. We call the rule engine no matter what. And but anyways, I mean, I will answer that question. So obviously, one of the issues is if we have low confidence on our ensemble. So we know that so we when we train the tickets, we only train on certain classes. We don't train on the other classes. So what will happen is that usually for the classes that we train on and we have sufficient data, we will get enough confidence on them. But the classes that we don't train on, obviously we will get, and then there are some confused classes. So mostly what we have seen is that on the confused classes and obviously the classes that we have not trained on, if the ticket comes related to that class, our confidence will be very low. And in that, so what we do is we target the confused classes. So it's like, I know that class A and class B are commonly confused. So I know that a priori that there is a very high probability that the confidence will be low. It may be that the confidence is high. If the confidence is high, we'll go ahead with the ML. If I say that 99% confident, okay, go ahead with the machine learning prediction. But if the confidence is low and we know that we may get it quite a few times, we will design rules specifically for the confused classes. We don't need to write rules for 400 classes. We need to write rules for only those classes. And if we get a low confidence, the rule engine will immediately catch that because it is specially tuned for those classes or for the low. So that's how we lower the probability that ultimately we will give out a bad classification. But I mean, obviously, I mean, we cannot ensure like 100%. There will be some times when we'll fall. I mean, the system falls through the cracks.
Okay, got it. Let's move on to the new question from the chat. This is, I think now it's correct for Arpit from Raghu. If the requirements are doing, or if the requirements are going to be domain specific, wouldn't bag of words be a better option?
Hi, Ravindra. So I'm not sure if I've understood the question properly. So if the requirements are going to be domain specific, wouldn't bag of words be a better option? So I am assuming that by bag of words you are basically pointing to the lexical approaches that are being used to extract noun phrases.
Yeah, I mean, simple point is word embeddings versus bag of words. You use word embeddings, so
right.
At least my, to the extent that I am aware of, I thought bag of words would be a better choice.
Right. So Raghu, there are two problems. So basically with lexical and the existing techniques, there are two issues. So one is that, of course, for small size requirements document, they are going to work fine. But when you're working with the large size requirements document, as I had also shown in one of the slides, that the number of noun phrases that we have managed to extract was something like 4,200, 4,156 or something. So of course, you will have to really, and of course, all of them are not equally important. In fact, some of them are just simple day-to-day words, which are noun phrases, but are of no use as a glossary term. So how to get rid of these, useless words? So if you use lexical approaches like bag of words and you extract noun phrases and then apply statistical filtering. So say each glossary term should have had appeared at least 5 times in the requirements document. Then of course you can reduce the size and maybe also include some important terms. But then the problem is that those terms which have only appeared once, twice or thrice in the document will not be part of your final set of glossary terms. The second issue is that all the lexical and statistical approaches, they don't take into account the semantical meaning or the contextual meaning of the term, which is very important. For instance, you can have a word which is probably a commonly used word in a particular domain and doesn't need to be a therefore doesn't need to be a part of a domain specific glossary, and therefore you should not have that word in the final set of glossary terms. But these kind of issues cannot be resolved using the traditional existing techniques that basically take into account text chunking for extracting noun phrases. So, I mean, the main problem is that you have to also, for each domain, take into account the contextual meaning, and based on that contextual meaning, you should try to, decide whether the candidate term is really domain specific or not. So, I hope.
Okay, that's okay. Thank you.
Yeah. One more question, Arpit, for you is, I think, again, this seems to be more a comment. You may want to look at approaches in terminology extraction and ontology creation. And he's also given reference to a seminal paper on that.
Yeah, I've just seen that, right.
Right. So you want to make some comment on that, or we'll just open up?
So I have not read that paper, so I'll have a look at it. So yeah, then probably I could say something. So I have not read that paper, so I'll have a look at it and then I'll see how close it is to the work that we have done, or can we basically try to improve our approach using that technique.
Yeah. Okay. Thanks. So I see Raghu has raised his hand. So Raghu, you can start off.
No, so I would rather wait because it's more philosophical perspective. So it'd be good to maybe do towards the end of the session. So I'll let the others, because I want to get Deepthi also involved in this in addition to Vikrant. So maybe just wait till the other three questions are done.
Yeah, sure. So Nandakumar, you are next. Can you unmute yourself and ask your question, and also maybe switch on your video?
Okay. I am Nandakumar. I have been a software engineer with ISRO for more than 30 years. My basic background is quality assurance. Here I wanted to make a general comment. This is not specific to any of the talks, but related to artificial intelligence and machine learning. The problems that are solved by artificial intelligence and machine learning are mostly related to classification problem, or based on a training data set, learning that, and then adopting and finding a label corresponding to for a large population. But can't we think of the other way around of generalizing the things? Like, for example, we have 100 questions are there for after a talk. Can we group them into 10 questions or 5 questions or 5 candidate questions? That kind of generalization and that kind of problems, can it be solved using AI? I wanted to ask. Anybody can answer.
So, Deepthi or any of you would like to comment on that question?
I think the easy answer to that solution is clustering. Okay, we already have clustering approaches to do it. Okay, and it does not require any training data. Okay, yeah. So that's the easy answer to that. If people want to add it, Arpit, if you want to add.
Yeah, so I think topic modeling clustering is one such technique which could be used. In addition to that, I think if the questions are very long, then you can probably even try to use text summarization, right? So there are these advanced text summarization techniques. If you don't want to go through the whole question and maybe there is a lot of irrelevant details, then you can probably first try to summarize the question and then probably cluster them, right, under some topic name, like these questions are related to whatever, like fairness testing and so on, and then probably try to pose these questions to the
are there real life examples of clustering solutions available in the AI domain?
Yeah, so clustering is being used. I mean, I can say, for instance, in NLP, clustering is being used for quite some time, I think for last 20 years now, and used very effectively for topic modeling, for generating summaries from large size requirements document, or codes, or for example, from code reviews and so on. So if you look at some of the standard techniques like K-means, EM clustering techniques, so they are being very effective. Of course, there is no one-shot solution for everything, but it depends on the context in which you are going to apply them. But they have been used for quite some time now.
Okay, thank you.
Yeah, thank you.
Thanks. So Sridhar, before I take your question, I'll get in Ravindra Medichella into the picture. So you have already asked a few questions. So Ravindra, can you go ahead?
Yeah, my question is, Adi, about are these presentations, right now videos are available, but there are a lot of references to some of the people. Are the PPTs or PDF of these material available somewhere for download by the people? That's the question, rather than anything related to the topic.
Okay, I think this is something that we'll take up separately, because we haven't asked the speakers to share their presentations. We have their videos, of course, available, and these videos are available on YouTube. You could open those videos and stop at the particular reference sections and look at those papers. But yeah, we will try to check it out whether we can even get the slides from each of the presenters. So before maybe Raghu, you take up again, I just had one question for Deepthi. So Deepthi, you mentioned about the coverage, and especially you mentioned about coverage of the models. So I was wondering how these data synthesis for testing, would it work for any of the AI models? And if it would work for any of the AI models, what do I need to know about the internals of the models to be able to say that what coverage I intend to have for that model?
So there are two kinds of testing, right? One is white box testing and one is black box testing. There are papers by Daniel Kronig and team, which actually defines lots of coverage criteria for white box testing, especially in the neuron levels. Okay, so there is something like a neuron activation pattern, okay, or neuron coverage. Okay, so for deep neural networks, there are lots of coverage criteria people have defined. Okay, boundary value coverage, boundary neuron coverage, and all. Okay, around 6 to 8 coverage criteria already exist for white box coverage. Okay, so which means for those particular model, you can see those, especially those coverage criteria, and see, okay, how much I have covered. Okay. For black box model, which means for any model, okay, there was none defined. Okay, because it has to be defined with respect to the some criteria which is interpretable, right? We do a path coverage and this thing, and for black box model, there's nothing interpretable. Okay, we just see the output. We don't see really the model. Okay, so what we did is, and what I presented is that I create a decision tree for any model, and with high fidelity, which means it has a very similar characteristics of the original model. And since it's a decision tree, now I can do a path coverage of that decision tree. Okay. That's the technique that we follow. Okay. And so for that, we don't need to know anything about the internal. It is giving decisions about the models. Okay.
So basically, it would work for any of the models then. Yeah.
It works for the structured data because it is easy to create a decision tree with respect to the structured data. It will not work for the image classifiers and all, because the decision tree gets really huge, and it'll not go into that level. Okay, it's going to be very huge. Okay, and so that's the thing. Okay, I mean, creating a good decision tree which is approximating a model is itself a challenge itself. Okay, and we have actually, there are papers which tries to address that problem. We have trying to make it better, and there are very interesting algorithms. Okay, how to capture accurately any model behavior using decision tree.
Okay. Thanks, Deepthi. So Raghu, you can take up your question.
Yeah. So again, as I said, there's no one answer, I guess, and it's not directed to one person. So please feel free to pitch in, Vikrant, Deepthi. So my comment was, the idea of a lot of times you say applications using AI, applications using ML, right? And we keep on writing IT applications, and then nowadays, because of the whole buzz, industry buzz, if I want to call it, or academic buzz, whichever way you want to look at it, we now call everything as AI applications, ML applications, right? And when you really think about it, your AI aspect or ML aspect is probably 5 to 10% of the entire application, right? But the entire focus has shifted to the algorithmic centric nature of these applications rather than the systemic nature of the applications. So, I mean, in a sense, we have started, at least in my lab, we have started using words like ML-ware applications, you know? So it's a play of words, right? Where you see, instead of saying IT applications using ML, we now say it's ML-ware applications, AI-ware applications. And if you're now looking at specific qualities, I'm starting to look at them as AI-aware applications, ML-aware applications, right? It's a play off of words, but I think that would be more apt to describe systems nowadays rather than just categorizing it in a generic manner, right? You want to be far more specific as we go forward rather than far more generic. That's just my thought. So I just want to hear you guys. What do you think about it?
Vikrant, you want to take?
Yeah.
Okay.
Just your opinions.
Yeah. So maybe I'll start. Okay. This is Deepthi. Okay. So I think you're correct. Okay. Because a complete application, the entire thing is not really a ML model or an AI model. Okay. Only a part of it. Okay. And but then, you know, since AI model and ML model are buzzwords today, we call entire application as an AI application, which even if there is a notion of feedback exists, okay, we say, okay, this is this is an AI application. Okay, any kind of feedback, and we consider taking those feedback and doing something in the runtime, okay, which considers those feedback as an AI application, okay, right? So those are the things, okay. But I think your correct terminology, as you said, okay, right? It's AI aware. The entire application is not AI. It's only a part of it which is AI, okay. And rest of the decision making is not really AI, okay. Even, I mean, people, we can say, okay, it's a rule based AI. So there is an application which is a decision making part of the application. There is other parts of the application. We just forget about those part currently, but I think those are an important part, and we cannot say that entire thing is an AI application, okay. So I think we can debate on the terminology, which is the correct on the terminology, but I guess that the point is that you're right that the entire application is not AI ML, and so classifying it as a AI ML is definitely probably not a good idea. Okay.
See, one of the other factors also is that when you start using AI ML in enterprise grade applications, right, when you move away from prototyping to putting these models in real systems, there is also a lot of engineering rigor that has to be put into creating these models, maintaining these models, right? So it's not just about the algorithm or coming up with a good model, but how do you get from day zero to a model that now works in a real life, a real world system on the ground is very critical. And especially when it comes to domains like life sciences, where you might have regulatory compliances to comply with. Like FDA has a soft medical device regulation that governs these models that are used in life science scenarios, where you have to show the auditability of that model as well, right? So I think going beyond the algorithms, putting these models and algorithms in real systems needs real engineering. And if you decouple them from the discipline of software engineering, that starts creating problems, right? So I think AI-aware systems or ML-aware systems is a good term, but then it's also important to couple the AI and ML work back to the engineering discipline that we normally take for granted in the more quote-unquote more traditional software.
I mean, just an aside comment. They always said, "What's there in a name?" And when Dipti said that, yeah, applications, AI applications are not completely AI. Just a part of it is AI, and that's how we have come to accept what AI applications mean. So by changing the name to AI Affair, or just by retaining it AI application, would the meaning of really what that application has, that there is a big decision making process in it along with some learning models, would that really make a big change? I mean, that's what I thought.
This is Sridhar here, if I can make a comment.
Yeah.
So I was wondering, see, to me, it's like software itself is a part of a bigger system. So we have systems engineering in that sense, right? No, software itself will help some domain. Right now, in the same context, when AI or ML is used in the software, now what is the role of that? Is it to an extent where it will influence the quality of the system to such an extent that it is so critical? I think there is a degree in which where I mean, this is at least my personal view that we do in our lab. So we start looking at, are we just applying it directly, applying an AI ML technique directly, or are we customizing it, or if I remove that, what is the effect of that on my entire system? So I think that kind of probably gives a glimpse of what is the role of this in the particular context. So it can be a minimal where it is AI aware, or it is like that, or it could be AI driven because AI is a main thing, or it could be even an AI thing per se. Yeah.
And yeah, I just want to add to Raghu's question once more. Okay, that there are certain problems we can only solve using AI. Okay, like I think the image classification, which were not possible really with rule-based systems and all. Okay, now even though there are engineering on top of the core component, AI component and all, like it is probably going to be better called as an AI application because it wouldn't have been possible with a rule-based system to even solve that problem. Okay, so we do have to classify terminology based on that, whether the possibility of there or not, or solving the problem was there or not. Okay.
See, adding to that, one of the things could be that there are always these labels which sort of help us to gain an idea about what the application is from the perspective of us being software engineers at times. So for example, if it's an AI application, the testing of it probably would be different, and you would have a different set of libraries that you have to use, or different skill set of engineers which have to work on that. And that is how I think much of this classification helps in general parlance. But yeah, I mean, it could be qualified as as you said. But I think that's my point of view on that.
Yeah, I mean the tough. I thought the difficulty is who kind of decides that it is really a AI application or just an AI aware application. So I mean, I presume it is really the owner or the person who builds it or who owns that product or part of the product is the one who's going to classify it. And as long as he classifies it in the right manner, yeah, the users would be able to judge from the point of view of testing or for the point of view of software engineering as well as to what it contains. But yeah, I mean, there definitely is a gray line and a fine line there.
Good topic for a paper.
Yeah, true. So I think we have reached. It's 1:45. We have exactly we started 5 minutes late, and we are ending 5 minutes late. So I think we have just met the timelines. I mean, I see Raghu's hand still up, but I hope he has no more questions. Okay. So thank you very much. I think this was a very interesting session. Thank you to all the speakers. Thank you to all the participants. We will be continuing the SERI sessions tomorrow morning. It will start at 9:30. So a request to all of you to join as you have done today. We've purposely kept this really half day so that you could continue with your other pieces of work for the rest of the day. So again, a formal invite, an informal invite to all of you to join tomorrow morning at 9:30. Thank you very much and have a good day.
Thank you.
Thank you.